Chapter 5.3, Add and Subtract Radical Expressions. First, we're going to start with something we know, like terms. Let's see how that works. We have like terms, x to the fourth, and all three of these. That means that we can add them or even subtract them. What you do is you add your coefficients, 1, 3, 12, 16, and you keep the same variable. Now let's do that with same with like radicals. To be a like radical or the same radical, you have to have the same index and you have to have the same radicand. Because remember, this can be written as 3y to the 1/5. Same index, same radicand. Here we go. Same index, same radicand. So they're like terms. Add the coefficients, 1, 3, 12. We get 16, and the same index, the same radicand, the same terms. Going on to the next. Unlike terms. Unlike terms would look something like this. The variables and even their exponents are not the same. We cannot add these. This would be your answer. What happens if we had unlike radicals? It would look like this. None of these are the same. So we can't add them. So this also would be your answer. Going on to the next. Unlike radicals, these are a little different. What we would try to do here is simplify them to possibly make them the same. So we're going to try to make them to be like radicals. We're going to factor two factors and make one of them a perfect square, cube, or the fourth, just like we did before. I'm going to pick two factors, one of them a perfect square, the number 4. Here for the 27, I'm going to pick two factors, one of them a perfect square. All right, notice that the 3 and the 3 will still stay there after I take out the squares. So let's see also if there's possibly a 3 goes into the 48. And yes, 16 times 3. So we have here, take the square root of 4, 2 comes out, 2 square root of 3. Square root of 9 is 3, 3 square root of 3. Square root of 16 is 4, 4 square root of 3. My indexes, my radicands are all the same, as if it was the same variables. So therefore I add or subtract it if I had that. I add, in this case, all the coefficients, 2, 3, and 4. I'm going to get 9 and the same radicand and index. Let's go on to the next. This time is unlike radicals. We're going to adding variables to it. Works the same way. They still have to have the same radicand and the same index. So we take two factors to give 50. It's 25 times 2. The 2 here will not go into divide into the 7. We have to bring it down 1. So it's 6 and 1. Here the x is multiplying. There's no addition and subtraction here. The x is multiplying this square root. But the radical sign is not doing anything at all inside with this x. So therefore, just copy down the x. Find your two factors for your 32. One's a perfect square, 16 times 2. 2 into 5 doesn't go evenly. Bring it down 1. 4 and 1 make the 5. And let's continue. Square root of 25 is 5. It goes on the outside. The next is 2. We can't take the square root of 2. It has to stay under here. X to the 6. 2 divided into 6 is x cubed. Square root of x, we can't take that, so the x has to stay on the inside. Continuing, we have to bring down the x. Square root of 16 is 4. The 2 has to stay inside. X to the 4th. The index 2 divides into 4 evenly without a remainder, so that's x squared outside. And here you have the x has to stay inside. So let's rewrite this nicely. This doesn't change at all. And over here, well, wait a minute, this is all multiplying. Remember, whatever we take out is multiplying. We have x times x squared right there. Look at that. And you know when we have the same base and you multiply them, you add the exponents. So we're going to get x to the 1, and x squared is now going to give us x cubed times the 4. And it's still times the radical 2x. Now let's take a look. We have the same squared index. We have the same radicand. So therefore we can take the coefficients in front, 5x cubed and 4x cubed, which is 9x cubed, square root of 2. Let's go on to the next. All right, let's see. We've got now same index, but certainly not the same radicand. So let's see if we can simplify these. Cube root of 8, 2, which goes out. 3 doesn't go into 4, so we have to go 1 down. 3 and 1 make 4. The cube root of 27 is 3, and we have the cube root of x left. Not quite there yet, but we're close. We have the index 3 divided into the exponent of 3, and that brings the x out to x outside, square root of x here, minus 3 square root, cube root of x. We have the same index, we have the same radicand, so deal with the coefficients, 2x minus 3. Well, they are not the same variables, so we can't do that. We just have to write 2x minus 3. Now, you're going to say to me, why did we put the parentheses? Well, if I didn't, then only the negative 3 would be next to this and multiplying it. The 2 would not, the 2x. But it's the 2x is multiplying it and the 3 is multiplying. We have to keep them together to show both are multiplying the radical.